Hello and welcome. My name is Diana Kelley, and I am the CISO at Noma Security. We're going to be talking about understanding the entire ecosystem of Agentic AI so you can know how Agentic AI works and also how you can secure and protect it. So to get us started, we're going to first take a bit from Gartner, right? Gartner tends to demystify things fairly well. And there's a lot of folks right now who just use the term agent like willy-nilly. It's Agentic AI. That's all you hear. If you were at Black Hat last week, it was on every vendor's, messaging, agentic. But what does it really mean? Well, these are intelligent agents. They're goal-driven software, and they actually take the promise of AI that is around LLMs and how LLMs work and take that promise and turn it into action. So let's look at some definitional differences. Generative AI does exactly that. It generates things. It creates information out of its training data. So you can write press releases with it. You can create new images with it. We love that it generates things because that's one of its big values. But very often the way that it works is that we put a prompt in and we get something out. So it's really sort of a one-to-one response. Sometimes people will call that being passive. Agentic AI is about taking the promise of generative AI and turning it into action and autonomy using software agents. You can use single agents or multiple agents, but you now use those agents to link together the outputs from LLMs and Gen AI, tools that you use for productivity like email and calendaring and other SaaS apps, and you bring them all together, and data lakes. Bring it all together to create a big system, a complex system that can do multiple different things for your organization. So simply put, Gen AI creates, it generates, and Agentic AI leverages that and turns it into action. The core working tenets of Agentic AI workflows are first to perceive. You gather and process data from different various sources. It can be data lakes, it can be real world information like temperature sensors, or it can be information that's stored in a database. But the point is that you gather that information. You then use the LLM for reasoning. So the agent has gathered the information and now is sending it to the LLM, the generative AI, to generate a solution, to come up with a response. Maybe I got a temperature reading on food that's being frozen at a retailer, and I want to know, should I raise that temperature or should I lower that temperature, or are things all good? What's the reasoning around that? And then taking the action. Once you get the response from the LLM, the agent or the agentic system can act on that. And over time, these systems work with feedback loops so they can learn to be more precise. The action is driven by collaboration. The agents have specialized roles and they're trained on specific capabilities. Then they use dynamic communication between the LLMs and the tool sets and share those insights to be able to update and act as needed on demand. The task distribution is distributed across the different items and components within the agentic system. Everything does what it's best to do. So the agents themselves, they can do orchestration and act. The productivity tools, they do what they do well. They store data, they have mail, they send mail, and then the LLMs do what they do very well, which is to think and then provide, generate new content and new analysis. As we look at this or think about this, how does this actually look in an agentic system? What might a good example be? Let's pretend that you're planning your dream trip to go to Venice. You have a calendar that your agent is instructed to plan that trip for you. The agent then reaches into the tooling calendar and pulls out information about what your schedule looks like coming up. That then gets fed into the LLM, which analyzes the best time for you to go on the vacation. After that, now you have the knowledge you need for the agent to work with other tools like websites to do hotel booking and flight booking. You can also connect to your banking system and you can pay for those hotels. You can pay for those flights in advance. And then the system can also talk to your HR team, alert your HR team via email that you're going to go on vacation, put that up on your calendar so that other people know. And you can also bring this to your socials and say, guess what? I just booked an amazing dream vacation. I'm so excited to be taking this trip. And all of it was done with the help of Agentic AI, tying all these different tools and solutions together. So now that you can see some of the promise of it, let's take a slightly closer look at how this looks architecturally. A lot of the components that I talked about are shown here. This is from part of the OWASP Gen AI working project, and this is a really fantastic resource. We're doing a lot of work at OWASP to help people have the resources they need to understand Gen AI and Agentic AI, including top 10s and threat information. So in this case, this is showing you Agentic AI, and as we see how it works, you can start to see the different components. And at each area of the components, that's when you start thinking about threat modeling, about risks, and about things that can go wrong. Those components are things like the LLMs themselves, the software agents that we talked about already. They can be done in a number of different ways. You can have a new build. You can do it low code. You could vibe code your agents. You can also do pro code. But the software agents themselves are those linking points no matter how you create them. There are classical tools in the system overall: databases, data lakes, productivity suites, and SaaS tooling. And then there are some new standards that we're going to talk about next that really help to tie this all together. The first one is Model Context Protocol. Think of MCP as the connector. What it is it connects your agents, your LLMs, and your local data sources in your tooling. It's an open standard. It was first developed by Anthropic in November 2024, and it's now been adopted by a number of big organizations like OpenAI and Google DeepMind. So it's becoming a true standard. But it connects the agent to the tool, so that gives you that power. How are you going to update your calendar? How are you going to know what's on your calendar to feed it to the LLM? That's coming from MCP, that connector into the MCP servers. It's also another point where you have to start thinking about threat modeling and risk. The other big protocol to know is agent to agent. This is the communicator. It's how agents in multi-agent systems can talk to each other. One agent may call a different agent in order to be able to accomplish a task that specialized agent. Remember we talked about how some were specialized? Maybe one agent can't do something another one can. So it calls that specialized agent. It's also an open standard. This one was developed by Google and it was released in April of this year. It's also getting wide support, and it's not an either or with MCP, it's a complement. So let's see those two working in action. So this is MCP plus A to A together. We've got two different agents. They're interacting with local agents. They can interact with each other thanks to A, but they're also interacting with tools and other systems through Model Context Protocol, or MCP. One last thing before we get into the threat modeling and the risks of Agentic AI is the autonomy spectrum, which is actually in itself a potential risk because agents can work across this spectrum. You can go all the way from a human makes every single decision and the agent doesn't take any action on its own, which kind of negates some of the promise of this tool. You can have a human in the loop to make assessments on very critical decision points, but maybe the agent does certain things that are lower risk, they're considered lower impact, and the human only comes in for some of those bigger risk decisions. And then you can do completely full autonomous agents. Which one you choose is really going to depend on your risk model and your threat model. You've probably heard about threat modeling. You probably know of Adam Shostak's 4 questions. What are we working on? What could go wrong? How do we address that? And how well did we do? So with those 4 questions, that's how we still need those in Agentic. But if you look at some of the classic threat modeling tools or frameworks like Stride and Pasta, they're not really AI aware. So Ken Huang at this for CSA came up with Maestro, the multi-agent environment security threat risk and outcome approach. So this is a framework that shows you two things. One is to look at the different layers. It does a system decomposition of the layers within agentic ecosystem, within agentic systems and agentic architecture. And he's broken it out into 7 layers here. And at each layer, you have to think about the specific threats for that layer. So for example, the foundation models, they matter. Which models are you using within your agentic system? Do you know what the risk is related to that model? You heard earlier today about the risk rubric.ai coming from CSA, which helped people to understand the overall risk or scorecard of the models that they're using based on different trust criteria. So that's part of that decomposition. You've got threats at each one of these layers that you need to look at. At security, you might start looking at, or compliance, you might start looking at bias or ethics within the systems. Within data, you might start thinking about risks and threats like data poisoning. So as you look across the 7 layers, you start doing layer-specific threat modeling and then cross-layer threat identification, because as there's lateral movement or privilege escalation through the agentic system, that's something that starts to tie together risks in the different layers. And sometimes they can create paths through the entire system to create a broader or more or a larger impact in terms of risk and attack. Once you understand all that, you can do your risk assessment and your risk mitigation and start to do the final implementation and monitoring. So what could go wrong? Since we don't have time to look at all of them, I've selected 3 that I think are really salient and important for people to know: tool misuse, cascading hallucinations, and rogue agents or unchecked autonomy. That would be autonomy that goes beyond what you want it to. So tool misuse first. This is when attackers access the tools that are integrated by the agent. We talked about email, for example. So using the email in a way that it's not intended. There's a classic example with indirect prompt injection where somebody sends an email that has instructions for the agent or the AI to take an action that is not good, such as delete every email in the inbox or delete every stored email. So it comes in as an email. The agent is supposed to parse that email. That's part of what it's doing, but it has a malicious instruction. And when the agent acts on that, then malicious action occurs. Another example would be not just delete everything, or it could be look within a set of emails and find a password that I need that somebody has hopefully not stored in their email, but if they did, just send me a password or something else that's a secret and send it to me. So tool misuse and mitigations that we can start to think about at this layer and with this threat: control access to the tools, make sure that the tools that are in use are helping to secure the rest of the system. For example, if you have DLP, it could look for any exfiltration of that the agent, maybe the malicious agent found, or the maliciously used agent found that secret password, but it can't pass it because it's blocked by DLP, and monitor the tools that are in use. So next one is cascading hallucinations. We've all heard about misinformation in AI and LLMs. That's when the response that comes out is not really accurate for the purpose that it was requested. I talked about temperature before. Temperature, for example, you could have a sensor that says the temperature is 20. The temperature right now in the room I'm in is 20, but it's 20 Celsius, not Fahrenheit. Now imagine if you're trying to cool food based on that information, how the data coming out, if it wasn't in context of what kind of temperature, what scale was being used, then the action could be damaging to the food. You might raise or lower the temperature too much. So the things to think about here are to mitigate our output validation. Make sure that you looked at the output and that it is accurate or purpose fit. If you have a policy monitoring, looking what your output of your LLMs or even your agents, you can see, is it something that's within policy or without policy? You can also look for optimization loops and add humans in the loop to ensure that as you're testing your agentic system, that it's operating as expected. You can red team your models themselves to make sure that they're putting out information that is considered aligned or appropriate and not misaligned or inappropriate for the response. So it's not, quote, hallucinating. And then ensure, again, that you've got feedback loops throughout the system. And then the last one to think about here is unchecked autonomy. This is when an agent goes ahead and makes decisions, takes action that could be very damaging for a system. There was actually an example of this where an AI bot told a customer to go ahead and buy a new ticket. The customer did buy a ticket. And then when the airline said, we didn't approve that, the customer took the airline to court. Now, if we were thinking about that in agentic AI, the bot may have actually purchased the ticket on behalf of the customer. So when the autonomy is unchecked, that means the bot can take actions that it shouldn't take. So you want to think about that autonomy spectrum and what you're doing for the purpose. It's very different if the autonomy is just generate a really pretty picture and put it up on the screen. That may be a very different level of risk, and autonomy may be differently acceptable than if it's, for example, review this legal contract that's binding and then sign it on my behalf, right? That we probably want to really check that autonomy. So how do we mitigate unchecked autonomy? Well, the first thing, you want to test the code of the agent, but very importantly, you want to dynamically test the entire system end to end within your production environment. You can also put rules on the agent, more deterministic rules. So AI is known as non-deterministic. That means that it generates new outcome. You don't know what it's going to generate at any given time. That's one of the the really beautiful things about it. But sometimes when we're doing things that are very need risk control and need to be risk managed, then we do want determinism, and we want to have very hard and fast rules. So for example, back with that bot potentially being able to purchase a new ticket for a customer, maybe we give a rule to that bot that it's not able to purchase a new ticket, or we have a human in the loop. It can purchase the ticket, but first a human has to approve that action. So you make sure that you put the right guardrails in place for the system that you're deploying, and ensuring that the security is really at that level that you need it to be. And then also monitor behavior in real time to look for anomalies or look for other activity that just doesn't seem right. Putting this all together, we now understand agentic systems, we understand the components of those systems, and we also understand how to start threat modeling for them, thanks to Maestro from Ken Huang and the CSA. And we have some threats to start looking at within the layers of the system, thanks to OWASP. As you deploy and adopt your AI agents and agentic systems, they're here, they're coming. It's not something to just say, hey, that sounds too scary. It's really good to start thinking about building them, adopt with care, know what you want to do with the agent, test, 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 and threat model so that you know where the risks are, what you need to do about it, and the controls and mitigations you want to put in place. And as you implement, be sure to monitor your agentic systems for activity to make sure that they're doing what you want them to do, they're not misbehaving, and that you don't have any attacks that are going through the systems or any layer of the system, whether it's poisoning your data or a neural backdoor in one of your foundation models. Finally, in monitoring, make sure that you're monitoring for any violations for your policies, and you're looking for that agency, especially the excessive agency, because when we do have agents, they can act, which is a fantastic part of agents, but we want to make sure that they act appropriately for our organization in a risk managed and monitored way. So thank you very much for listening, and I hope you have a great rest of the day.